Welcome everybody. This is a micrographics webinar on available AI leveraged against AEC Collections. There's a bit of a delay on our feed, so we'll start in a moment or two. I can see that we are live on the screen. Welcome, it's 10 o'clock. We'll start with the webinar, available AI leveraged against AEC Collections. My name is Paul. I'm from Micrographics. We're an Autodesk reseller. And this morning we'd just like to give a general overview of the available solutions that there is in AI and what you can do using your AEC collection, and what might be the easiest way for you to get involved. On the agenda today, we're going to look at something that we call the McLeamy curve. It's an industry curve that has been developed over the years, and we'll look at the changes that's bringing about and how, as a business, we can reference our development with regards to our project modeling and our project program based on that curve and the technologies that are available. Then we'll also discuss Dynamo and Python and how to ask MIMO questions. So Dynamo and Python, that is a technology that's very developed quite extensively within the Revit environment, and it's also available in other platforms, for instance Civil 3D, AutoCAD and some of the others. And then generative design, how to optimize MIMO questions. So we'll discuss what MIMO questions are, multiple input, multiple output questions, and what generative design is in principle. Then we'll look at a new development, relatively new development, Autodesk Forma, and how that democratizes AI, or artificial intelligence. Then some further considerations. Daisy AI for wooden structures. That is also a platform that's been developed around Revit. Evolve Lab, they've got a few interesting solutions that you can invest in. And then we're also just going to do a quick discussion about repurposing and retraining your workforce. Here is the McLeamy curve, and it pays to have a look at this. First of all, we'll see that we've got two axes. The vertical axis is the effort or the effect, and the horizontal axis is time. At the base axis, we can see that we've got the preliminary design phase. You'll recognize this if you're in the industry from the development of our projects, the preliminary design, then the detailed design, the construction documentation phase, the construction phase, and the operational phase. So think about it as a timeline spanning the phases of the project or the stages of the project. Then we've got this graph over here, the light gray one, the ability to impact the project. So as you can see, with most things, at the beginning of the project, the decisions that you make will impact the project greatly. And it quickly diminishes, and as you get further down the project, the changes that you make have less impact. And what you should note with that is the cost of the design changes. So you would have invested a lot of effort to get to somewhere the stage in the timeline. And if you make a design change, that's going to impact the workflow upstream as well as downstream. So some of the work might have to be redone, and then the cost will increase. Or you'll have to do more work to redo a design due to the cost of the increases. That's a relatively simple graph to understand. Changes at the beginning of a project have a huge impact. The further down the line you make a design change, the more costly that will be. Then we've got these two distributions. The one is the BIM workflow and the CAD workflow. And you can imagine the CAD workflow being a traditional AutoCAD workflow. For most of us in the industry, we would have, at least people of my age, we would have started out with AutoCAD in the 1990s or earlier, and we have done an enormous amount of good work with AutoCAD, but it is a traditional workflow, CAD workflow. It's not a BIM workflow, it's not a building information model as such. 2D paper drawings, maybe 3D, some more verticals. Okay, but you can see how the amount of work that's done at the beginning in these CAD packages is less than what we would do with something like Revit, where that steeply increases and we peak around the detailed design, drop off sharply towards the construction documentation, and then we slope out of that. Whereas with CAD workflows, most of the work is done during the construction documentation phase. So more work done in Excel and traditional ways of working. With BIM workflows, we integrate that information into the model. More time spent modeling and designing, less time spent on the construction documentation. So that's the traditional way of working. And I think most of us would agree that the CAD workflow is accepted now to be less efficient than a BIM workflow. The most potent example of that I normally mention is that in the 1970s and the 1980s, on the construction of a large project, if you can imagine something like $1 billion skyscraper, 1/5 of that construction cost would be blown on clashes, where the entire site will come to a stop and we'll have expensive clashes to fix. And that would be a traditional CAD 2D workflow. And just by virtue of the fact that we're doing a 3D model and that we can clash detect, that will already save us 1/5 of our construction cost if we do it properly. All right, so that's the most easily proven example of why BIM would be better than CAD, just in terms of a cost perspective. But there are many more advantages which makes it much more effective than the CAD workflow. The other thing that we need to note here is that the cost curve shows how early design freeze is the goal. All right? We want to get to a stage in the internationally best accepted practice for BIM, or ISO 11650 these days. We would say we have an exchange information requirement by the owner of the project or the client, for want of a better word, and they would sign off on a design round about just before we get to the detailed design stage. So right about on this dotted line, that's where the client will sign off on the design freeze and say, I'm happy with what you've proposed in the preliminary design, get on with it. So from there onwards, if the client stays out of the process and does not effect a design change, which is costly and has less of an impact on the building, then the production team can get on with the BIM workflow, finish the detailed design, go through the construction documentation and construction phases, and hand off to the client at the operational phase. So the client's involvement is very important during the preliminary design until the design freeze, and then from the operations through until they are operating that building for the next, argument's sake, 60 years. The question is really, how will this curve? We are now at a stage where artificial intelligence is becoming a commonly accepted work. There's a lot of people that would argue the fact that most of what we refer to as artificial intelligence isn't that, but it's more machine learning. But we'll talk about this as if it is the generally acceptable term of artificial intelligence, including machine learning. And the impact is profound. Firstly, the curves of the ability to impact and the cost of design changes, they stay the same. It's still a curve that slopes up for the cost of design changes and a curve that slows down for the ability to impact. But the ability to impact is not changed. So, this is the first thing to notice. This is the big change, one of the big changes. Our decision points, because our tools are now faster and can react faster and generate faster and automate, we are flattening this curve and we are changing our ability to impact straight into the construction documentation phase. So if something happens and we need to make a change, then we can still make that change without impacting the timeline too much. But note, even though you can affect that change, it will still have, if you go down onto the cost curve, it will still have a cost implication. So the goal would still be the same if you're looking to maximize your profits, and that is to have the earliest sign-off on the project. And here's where it gets interesting. We now have what they refer to as an outcome-based design workflow, which in essence means that the tools that we have at our ability now gives us the opportunity to present a much greater and a much wider range of design solutions and options for the owner or client to be more satisfied with at the end of the preliminary design phase. In plain simple English, we'll come up with a much better optimized design based on client requirements and expectations at the end of the preliminary design, and we stand a much better chance of the client being happy with what they're signing off on. Less uncertainty and a much bigger propensity for saying, get on with it. I'm happy with what you've designed. Do the detailed design, construct it, and hand it off to me towards the end. And this is then where most of the effort will go into the project. Just like with the previous distribution of work. So you can think of the area underneath these graphs, although it's not mathematical equations at this moment, but you can think of the area under the CAD work as translating into work done. And of course, for work done, there is a monetary requirement. So based on a traditional CAD workflow, the amount of money that is spent happens during the construction documentation. That's where the cash flow becomes important. Similarly with a BIM workflow, it's earlier, it's during the detailed design phase. That's where most of the design, at least from a design perspective, if you're on the design team. Of course, this doesn't look towards the actual construction project or the project management or any of that. It just looks at the design workflows. All right. So from a design workflow perspective, from the design team side, the amount of money that is required is earlier in the project. So again, that's something that the industry understands. When you go from CAD to BIM, you need to have more money that is released at the beginning of the project. And it's even more pronounced when artificial intelligence is employed. Because now, most of the work is done right from the onset, right from the beginning. There are various nuances in this, where one would, the typical uninformed consideration would be, well, it's machines that's doing the work for you, and therefore, why would you need money? Well, putting that technology to work takes money, and we'll look at some of that after this. So the cost of the design changes is still the same. The goal is still the same. Get the client to sign off after the preliminary design, get on with the job. But the majority of the work is put into coming up with a better design. And it says, again, fast early designs changes allow one to lock down the design earlier and consumes most of the effort. Right. So it's a pretty simple graph to understand, and it should guide us in our acceptance of the technology and taking it through there. So Johnny, is it just my speakers, but I'm struggling to hear? Johnny, I've got my telephone on the side here. I've just switched the audio on, so I suspect the issue might be on your side. The audio is coming through clear on my cell phone. I've joined the meeting on my cell phone on the side. Maybe just have a look at your audio settings. It's possible that you are perhaps hooked up to the incorrect speaker, maybe not your headphone but your computer. I'm not sure what would be happening there. Apologies, Johnny, if you can't hear. I do think in this case that the issue might be on your side. Just note that there will be a recording available online after this webinar. You are most welcome to re-listen to the webinar afterwards, and then if you have your audio sorted out, you should be able to hear what is coming through. So if anybody else has issues hearing, just let me know as well. Then, but I don't think the problem is with the actual webcast. All right. So with the business considerations, the McLeamy curve. This is also some interesting data that came out of some projects. The value creation that happens in the beginning. So it's estimated that about 50% on a typical building, 50% of the value creation for residential development happens during the preliminary design and the detailed design phases. And this is also where you can get most of the value for your money, is during those first phases. Right. So that's the business case for artificial intelligence. It makes a lot of sense. And then we're going to go on to what you can do with your AEC collection. First of all, Autodesk Dynamo and Generative Design are the most versatile tools for those with the skills and intellect within their companies can leverage the technology to compete on the global stage. All right. And to use Generative Design and to use Dynamo and to use Python, you only need a Revit license. A Revit license is sufficient. You don't need an AEC license. You can have a Revit license. And in essence, what is happening here is that the Generative Design platform is something that Autodesk has put together. I'm just putting the link onto the screen there. And here's a good example of an area I'll just explain to you while that video is playing. It's an area somewhere in a city, and various different building designs are being designed. And there are various criteria that play a role here. So anything from sunlight, the views that we get, the optimization of the workspaces, the energy usage, anything that might be important to the owner or operator is represented in this case on a little cube at the bottom right of the screen. You'll see it appear over here. And these are different dimensions. And a value for each design is given within that envelope. And the idea would be to choose the design that is most relevant to the client. So if an engineering team had to do this, it would take a long time to come up with one solution. But if generative design is used, then we can get a quicker solution coming out of the desirable outcomes. So this is what they refer to as the outcomes-based solution. We start with the outcomes. We create an axis for that outcome. We say, how important is sunlight? We can see some of these designs, if you just look at that little vertical axis, some of these designs that are being come up with are not that great. And eventually we'll come with a design freeze and say that is the solution that we'll go with, and that will correspond to some other point on that axis. So that's the generative design primer. And these outcomes, those 6 axes, it might be many more. On modern computers, they talk about billions of variables that people control in these systems, not within our industry, but within other industries. And what they refer to that is the multiple input, multiple output optimization. So they've got X, Y, and Z here. The reason for that is that they're dealing with a shape, so it's by way of explanation. But you can increase these variables. And as you increase these variables, then you'll have more sliders with which you can play. Now, the solvers, they would be governed by a mathematical or programmatic structure that will come out with a solution. So if X is a 0, keeping Y and Z the same, we will get a specific result. If we increase X to 1 and we solve, then we'll get a specific result. This is excluding things like the sensitivity or the chaotic nature of the solvers. Those are exceptional cases. But in general, we would have some other relationship between the variables, a function of X, Y, Z, A, B, C, D, E, F, G, H, I, J, K, up until however many variables. We'll change one variable a little bit, put it into the solver, come out with the solution. The solution, in this case, again, it's not very well shown, would be something like one of those outcomes on those 6 axes. So it would be a solution for the 3-dimensional shape. It would be a solution for the sunlight. It will be a solution for the views. It will be a solution for the productivity. It will be a solution for whatever criteria we've put into the system. And the idea behind this, it's a bit like a brute force attack by a computer on a mathematical relationship, is we'll define through which values X should step, and what is realistic within our expectations. And then what we'll do is we'll step it once, do the calculation, come out with a solution for all the variables. Do it again, do it again, do it again. Maybe do it 100,000 times for X, or 1,000 times for X. And then we do the same thing with Y, and we do the same thing with Z. And then we might want to increase the value of Y a little bit, and then step through X again. Increase the value of Y a little bit again, and then step through X again, and then again, until we step through all the values of Y, step through X. So we'll have to take all those variables and step through the entire design envelope of each one of those variables that we might input. That's a multiple input system. For a human to do that, for each change that you make, you will have to solve the equations and come up with the solutions. But if you set up the solutions in a system of equations, then you can get a computer to do the calculations with you. And that's where the power of generative design comes in. So the important thing here is, from a modeling perspective, from a transitional perspective, should we say, is being able to ask these multiple input, multiple output questions of the models. One is, okay, we need to treat the BIM models as data containers. We are used to buildings as architects maybe. They must look good, they must be interesting, of good quality, etc. But we might not be that interested in exactly how we model components or how we code components. When we say code components, we mean we are using standards. In South Africa, it might be the Association of South African Quantity Surveyors, so that we can identify components. We might use a different classifications, Unicode or Uniclass, or whatever classification system we're using, just to classify our data and to impart information onto the data. We could use COBE for operational management, recording information into those BIM elements. And that's what makes BIM so powerful, is you've got this three-dimensional model that you can clash detect, but at the same time, you can also impart data on those elements. So treating the BIM models as data containers, essentially databases, allows a programmer to design a multiple input, multiple output question with Dynamo. So if you can think about it, it makes sense if the calculations that we are performing on a model will only make sense if the model makes sense. So that's why we must construct the model in a way that would make sense to the programmer. And we must make sure that our models comply with it. Again, the questions can be constrained. So let me give you an example. This is where I first came into the understanding of how powerful this could essentially be, and which also illustrated to me the complexity. We were busy modeling some of the biggest hospitals on the planet, and I was employed as a programmer in Dynamo and Python to automate some of the production line activities, and on very large buildings that can take a lot of time, and it was successful to varying degrees. And one of the questions and one of the conversations that came up as well, it's very expensive to build hospitals. The cost per square meterage is astronomical. But now think about how complex it is. Let's suppose you've got 5 medical operating theaters on a floor. You would have to have auxiliary services to those theaters, or spaces, rooms, waiting rooms, supply rooms, whatever it is that you need. And there are usually, architecturally speaking, or whichever discipline you're in, there are usually logical rules that you could say. So we could say that for a operating theater, you need a storage space of at least so many meters, and it must be accessible via a double-sided, or a door that can open to both sides, or we might need to have a wide hallway that connects certain rooms. And the rules governing that is not only spatial, three-dimensional spatial, but it is also based on the operational requirements of those spaces, and these need to be mathematically and logically depicted within a question. And in addition to that, we then need to run through the various scenarios, maybe a few 100,000 scenarios of, or a few thousand scenarios of what we might get if we had to step through the different variables, and what will be the most efficient outcome. The chances that a human being comes up with the most optimized solution would be small to none. It might be the best person in the world, but the computer can go through all the scenarios and give you maybe a better solution. Right? And if you can minimize the area, then you're minimizing the cost of the building. And if you are a hospital designer, then you can compete against, for argument's sake, China, America, England, Russia. From a design perspective, you can come up with a cheaper solution doing the same job, more optimized, perhaps a better solution that you can then apply that model, or maybe tweak the model a little bit, and then apply it to a different country with different rules. But you would be developing a model which is applicable to that specific area of expertise. In general, with the optimization of office layouts, and Autodesk actually did some great work on this on their San Francisco office, they actually did this. They did exactly that. Not on a hospital, but they did it with an office layout. Daylighting, window views, ease of access, energy usage, and productivity. Those were the different requirements that were asked. And they came up using computers and their expertise with the most optimal solution based on what the client decided on. Now here's the catch. Setting up these questions require a high level of intelligence and might require you to spend money on the talent and research and development required. However, if you get it right, you can take on the world. And what are we talking about, a high level of intelligence? Would it be an architect? Well, you do get very intelligent architects. But an architect is not a mathematician. An architect is not a programmer. And an architect is not a physicist or a statistician or an artificial intelligence expert. So those disciplines which I've just mentioned, those would be the types of people that we should look to, if not lead within the industry. There are other things that might be more important than having a mathematical knowledge within the industry, but to set up these models and to develop these models, we need very highly skilled, inventive, intelligent people to drive that process. And we might not have that. I know I don't. I've tried my hand at this, and it's above my level of expertise. However, I studied engineering, but I've got friends that can do this. I've got a friend that got his mathematical doctorate at the age of 21. And I know that he could do this. And if I had a company, I might go and say, well, I know somebody like that. Let me go and sound them out and say, are you interested? Would you like to take on something like this? Let's try and see if we can develop a model, for argument's sake, around hospitals, and come up with a recipe, a solution, a model, specifically a model, a MIMO model, where we can go and market our services to the rest of the world. So first of all, come up with a solution, prove the solution, improve the solution as we go along, fine-tune the model, and ultimately go to other countries, other governments, and say, we've got a low operating cost in South Africa, we've got the ability to design hospitals even better than you can, and let's do it. So that might be an example of how such a model could be leveraged. And that could be in any discipline. It could be in architecture, it could be in hospitals, it could be in healthcare, it could be in education, it could be in whatever model you are putting together. And some of the technology will cross-pollinate across the different disciplines. So, you know, once we get one thing right, then one can go on to the next. So posing the Dynamo MIMO questions to the model happens in Dynamo. Generative design optimizes the solution for those questions. That's the basic premise of what Dynamo can do in conjunction with generative design. Pitfall is, depending on the complexity of the MIMO question, this might easily involve hundreds of thousands of iterations. It could take days, maybe even longer, running through all the different scenarios. And making mistakes in setting up the models and posing questions will be costly. So if you make a mistake and you run computers for a week, for argument's sake, it's going to incur a cost. So you want those models to be accurate. It is always a risk, but it is a risk worth taking. And then you also need some good hardware to perform these calculations, as it does not run on the cloud, but it runs on PC. So when you run Dynamo, when you run generative design, at least within a Revit model using generative design, the calculations are not done on some cloud computing platform where it can do these calculations for. It's done on PCs. So one would have to get a good PC, a very good PC. The better the PC, the faster the iterations. And you can then develop those models. And it might take time. So there are pitfalls, there are dangers. Now we get to the interesting side of things, where if you have so the header of the webinar, or the title of the webinar is how do you leverage AI against your AEC collection, right? So what's special about the AEC collection is we've got Forma. Forma is new. It's not, the concepts aren't new. The concepts of Dynamo and generative design have been around for years. But Forma hasn't. Forma is taking the place of Form-It, which used to be a sort of general modeling package that we use within the industry. A guy sitting on his iPad and he wants to see what a shape looks like, and he takes the shape into Revit, and then, you know, it's a shape model. Now they've gone one better and they said, all right, let's get rid of Form-It and get Forma. And then what we're going to do with Forma is to add artificial intelligence, generative design, machine learning into that. And what can we get out of that? We can get area metrics, sun hours, daylight potential, wind, microclimate, noise, solar energy, and others, extensions that would have been developed by other people. And so that is a very good solution to use. Just want to open Forma on the side here while we're busy, and I'll just want to show you the platform itself. Sorry, I've closed the portal inadvertently. My apologies. Won't take long. And these are the easy things that you can do without investing in programmers and intelligent people. You can just use the software. It's just there. It's available to you. And that is how you can get that beginning curve to come out. So what Autodesk have done is they've democratized the platform to give you already developed and proven solutions that is using this generative design capability in the background over and above some of the generative design scripts that might be available to you within your Revit and Dynamo or your Revit player. So we've been playing with one of these models, or with the technology here at Micrographics, both myself and Sean and Christian, and I'm just loading up a model that we have, and here you can see that you've got all these modules, including the wind design. And if you look at the detailed analysis results, you can see if you wanted to do a new analysis or analysis, then the bigger you choose your radius, then the longer the computer will take to run through it. Right? So to do one wind analysis for a shape, this might take 155 minutes on the outside. If you decrease the radius of the wind, then it takes less time. So it's all time dependent, right? I don't want to run a new design. Okay, so there is an analysis for the wind that one can view. And you can see how it incorporates some of the green building technology with the windrows. This is where the most wind comes from, on the southeast. and sometimes the wind comes from a little bit more south. There's also northwest here in Cape Town, and it was so pronounced in Cape Town, in fact, that we've had August tours cancelled. So there's a lot of statistics. You can put the streamlines on as well. There you can see some streamlines that are coming through there. You can visualize how the wind is going to blow around that. There's the speed. If we increase the speed, the pressures that's existing around the building, you can imagine if you have to walk through corridors like that. So it's a bit of computational fluid design happening here. And as you change the windrows, so the curve changes, and you can see how the wind is blowing around the building there. Right? Turbulence, laminar flow, all of that becomes available to you if you use this tool. And this is available to you already within your AEC collection. So this is where we climb onto the McLeamy curve and we give the client a solution. The client might state, well, look, I want a nice building, but I don't want the people to be blown off their feet in Cape Town. And in Cape Town, for instance, we have to do ultimately a wind tunnel analysis with the CSIR, or National Standards Authority, basically. They've got a big wind tunnel with the entire city, and then they'll put your design in that wind tunnel and test it ultimately. But you stand a better chance of passing, a lower cost. You know, if you come into the wind tunnel with the design that you know, based on these analyses that you've run for a while, you're going to come up with a better design, then you don't need to worry too much about the wind tunnel failing or passing your design. So that's one example with the wind of how you can use this preliminary design, just the shape of the building. It's at the preliminary design phase. How many floors does it have? What's the shape of the building? And how is that going to impact the development of the town? From a planning perspective, you could even go further and say, as a city, as a smart city, how are we going to pre-approve building shapes that we might use within our town to mitigate the effects of the wind on the pedestrians on the ground? And there might be, it's one thing if the people are in the building, on the upper floors, the pressures, besides blowing windows out of their frames, that might not be that important. But what's more important to us is how is the comfort level of the people on the ground? And then we'd say, okay, we're pre-approving this shape over here, and on the next one we're going to use a different shape, and then we can plan the flow of air through the city. Okay, so, and you might interface with national authorities on projects like that if that's within your sphere of influence. So Forma is available to you within your AEC collection, and this is possibly the easiest way for you to get onto that earlier curve of the McLeamy curve and to make the biggest impact on your design as you are developing it. So that is Autodesk Forma. Great tool. I don't have as much opportunity to use it as I would like. Then again, I'm not an architect, so I just hope that if you are in the business that you are paying attention to that, and that we are using these technologies for the advancement of our industry. And then we've got Daisy AI. Now I know in South Africa at least we don't use the wooden house design so much, although it is commonly accepted worldwide that wood is a renewable resource. People are building big skyscrapers with wood these days in Scandinavia and North America. As long as you plant more trees than what you take out, it's not such a destructive technology as, say, bricks or mortar. And this is called Daisy AI. Daisy AI, you do get a trial as well, which is nice. And it's got a plugin for Revit. And there's definitely some very interesting things that you can do here. Also doing structural analysis on wooden frames. Not so much steel frames or anything like that, but wooden frames. So if you're into the wooden framed housing market, this would be an example of where you could come out and optimize your designs and bolt that onto your Revit designs and come up with the best solution in the shortest amount of time. There's a floor plan design and optimization, stair design and optimization, roof plan design optimization, wall framing, and a full timber house design. So that would be something to give to your R&D team and to say, guys, let's go and have a look at Daisy AI. Based on the cost that we're paying, is it going to be worth our while to employ that technology when we do our designs for wooden housing? There's also Evolve Lab. This was a very interesting question that came through at about the same time as what the artificial intelligence generation of images came through. You can go onto an artificial intelligence platform today and type in anything you want, and it will come up with a picture for you. And the thinking behind it came in from a client is, well, is there anything in the AI sphere that can help me with my architectural renders? And the answer is yes. And that's specifically called Veras. It's within the Evolve Lab environment. They've got various assets. There's Veras, Glyph, Morphos, Helix, and Bento. Veras itself, there you can see an example by putting in different keywords. It will give you a different context, different materials. You can just essentially put it in, it will come up with a generation of that material and the context. With Glyph, that is more about sheet creation, view creation, and so forth. And that might be more Dynamo than AI so much. So some of these packages there, you can see Morphos helps to design. Let me make it a bit bigger. Helps to design, say, your office spaces and your optimization. It's giving you a few of the inputs that you can play with and see how it comes out with. Helix, this can interpret a SketchUp model into Revit or an AutoCAD model into Revit. So if you design something in SketchUp, then it will recreate that for you to the best of its ability within Revit. You probably have to load the right families and everything, and then we've got the Bento, which has got to do with point clouds and so on. So there are various solutions out there. The rendering one, I think, for most architects would be the most interesting. And that is the Evolve Lab platform. All right, and then just a quick word on the repurposing and the retraining of a workforce. AI and automation makes traditional workflows and workers redundant. We've seen that worldwide. And the challenge for business is to make an investment in their existing worker base in addition to investing in new technology. So it's very easy to say, oh yeah, we're going to take new computers, we're going to employ a bunch of clever people, and then we're going to come out with better designs and we can get rid of our workforce. Right? Human resources is still your most important asset. And the reality is that you will compete against other people or other companies on the planet that's going to use their workforces. So I would recommend not to see redundancy as an opportunity to get rid of jobs, but instead to repurpose and to train your workforce. Might not always be possible, but in general it is. So another big thing is encourage and welcome competition and startups. It is an evolution of technology. And just like evolution, there are rules. If you welcome competition and compete against them, then that is good for you. You will, if you are the fittest, you will come out on top. And startups, business, well, I'm not a businessman as such, I'm a technical resource at an Autodesk reseller, but just from listening and watching business in general, it's, if you wanted to open a new food retailer, you might find, or a new fish and chip shop in your town, there might be already a guy selling fish and chips. So what do? You come in and you mark down your price, and you would try and get a competitive advantage over the other guy. So competitive advantages are good, but startups should be welcome because they are going to bring new ideas into the environment that we operate in, and they might ultimately end up complementing us as opposed to opposing us. And so the industry will evolve, and we'll adopt a new technology and do new things with the technology. It's my bugbear, the second law of thermodynamics, right? It's like the sun coming up in the morning, or if you take an apple and you drop it onto the ground, it's going to fall to the ground. You'd be a fool to bet against it, right? Just so it is also the second law of thermodynamics. In the way that I'd like to interpret it in this case is to create order, and in this case what I mean is modeling your models in a specific way, coding them in a specific way so that a programmer can leverage a logical set of equations against that model, employing AI and automation. In short, you will be surprised, but I've seen this in more than one instance, it will create more chaos than the order it tries to impose. Because people have to learn new things. You have to do new things. You have to retrain. There's so much that goes into this, right? And at least when adopting the technology, you're going to find that. And what this means is that more energy is going to be required to maintain the order. So if you're operating on your own, it's difficult because you're a single-man business. You maybe can't do all of that. Maybe you then use Forma and use it to your advantage and leave the other things to guys with bigger teams. But maintaining this order, work begets work. When you go into a shop and you make a chair, the shop is going to become dirty. There's going to be shavings everywhere, and you're going to need to clean that up. Okay, so you might have to employ somebody to do that, to sweep the floors, clean the machines, and do that. And this is exactly how this process is going to, will work, does work. It's like robotics within manufacturing. Somebody has to maintain the robot, somebody has to service the robot, somebody has to design the robot, somebody has to program the robot. And that's where the retraining and repurposing comes in. Better jobs, better skills, and better productivity, ultimately more successful companies, in theory at least, and also a better pay for workers. This is exactly where the creation of jobs will ensue. So that is something within South African environment sometimes that we don't understand, that it is a law of physics, and that just like the sun coming up in the morning or an apple dropping to the floor, it is what will happen. So just be prepared for that. There is going to be chaos when you try and create order, and more so if you're employing computers to do optimization for you. And so just in the last sentence there, if the correct attitude is maintained, keeping that airplane in the sky, and responsible risk is taken with respect to investment and research and development. It's very easy to say, oh, fantastic, here's a new technology, let's go and do it, right? But then you might overextend yourself and close your doors, and something good or something great or something that might grow exponentially, that will go bust. So, it's good to take risk, but it's also good to do so in a responsible manner. Okay. But when people see that it works in their advantage, when your workforce sees that it works in your advantage, then they won't push back against it. They'll actually welcome it. And that is also the welcoming environment that the technology that we use, that is the impact that we should have on not only our communities, our clients, better buildings, more efficient buildings, return on investment for the client, but also for the industry and for ourselves to welcome this new technology, to adopt it, and to employ it. So in conclusion, I'd like to say it's important to stay ahead of the technological curve. Look what's coming. It's not always a reality. Sometimes there's a lot of hype. You shouldn't buy into the hype either. But having an R&D department is important. And investigating new technology is critical. If you operate in a competitive environment where AI is a nascent technology, then you need to at least investigate how you can gain benefit from investing in it. Even if you don't invest in it, just do a cost-benefit analysis and think to yourself, is it worth it? Revit Dynamo and Generative Design is the most versatile solutions provided, that you can pose the questions and do the optimizations yourself or with your team. And it's available to you even if you only have a Revit subscription. So in other words, if you want to take the difficult route, then having a Revit subscription is sufficient. But if you have an AEC collection, then you've also got access to Forma. which is an easily usable solution that democratizes some of the commonly accepted solutions of the preliminary design. We had to look at the wind within Cape Town. You might just easily go, okay, so how can I optimize sun so that I can get solar power, and so on, right? But that's then available to you. You don't even have to do clever stuff. You can just input the model and see what the effects are. Give yourself enough time at the beginning. Have a computer that you run this on repeatedly until you get a nice solution. Okay, the client's going to be happy, signs off, freezes the design, and you get on with production. Okay, and then repurpose and retrain your workforce to adopt new technology, even if it's just in the research and development capacity. So, yeah, maybe take a small pilot project or scenario, and you know, if you've got the money and you're prepared to blow a little bit on, hey guys, let's see if we can get this working, and then see the result and think, all right, can we now use that on a project and maybe see if that's going to make it better for us, right? So maybe take a risk and see, does Forma, even if it's just Forma, can I use Forma? How is it going to change things? You know, that would be a good idea. And so we're coming to the end of the webinar. But thank you very much for attending. It's been a privilege having you here. And Johnny, if you want to go and have a look at the webinar recording, I'm sorry about your speakers. And hopefully, if you have any questions, or if you want to follow up or just chat about it, we're at Micrographics, and we're in South Africa. But our contact details, www.mgfx.co.za is our webpage, and info@mgfx.co.za. And hopefully we've added to your understanding of, if you have a Revit license, if you're an AEC license, you can still get onto the forefront of the technology because of that democratization within Forma. So unless there are any questions, we'll just hang on for a minute or two. Unless there are any questions, we'll conclude there. I'm just going to wait a minute or so just for the time lag, just to see if there are any questions coming through. I'll just quickly respond to Johnny as well. All right, thanks guys. Have a great day further, and hope to hear from you soon.